Good afternoon and welcome to this workshop of the International Road Federation. My name is Susanna Zamataro, Director General of the International Road Federation based in Geneva, Switzerland. I'm very pleased to welcome you all to this workshop on innovation, driving the future of sustainable mobility. You will have to be very patient with us today. It's the first time after a long time that we are meeting people in person here at Intertraffic Amsterdam and broadcasting this live at the same time through Zoom. So that has complicated a little bit our logistics, but a big thank you, first of all, to my team for putting all the bits and pieces together for us to be able to enjoy what I'm sure will be an interesting conversation this afternoon. And I want to start by, if I manage to change the slides, here we are. The agenda for this afternoon, we will have 1 hour, 30 minutes. We're going to close this down at 3:30 Amsterdam time. We will start with first two presentations. And here again, we are already in the very first part in the hybrid. We will have Mike Evans joining us on remote, and then George Yanis in presence. They will be setting the stage for the conversation today and really talking about how do we need to rethink transportation systems? What does that entail? Because if I were to ask here today, what is the first word that comes to your mind when you say innovation? I'm 100% sure that 90% will say technology. But when we talk about innovation, there's a lot more that we need to take into consideration. So it's, yes, indeed, technology, it's data, it's all the technology and innovation that goes into infrastructure, but it's also the innovation when it comes, in fact, to rethinking and reshaping transportation systems. And that's probably where our sector is struggling a little bit. We are a very traditional sector, so lots of technology and innovation, but when it comes to take a step back and look at things from a higher perspective, that's where we sometimes struggle. We will then have a session on specifically zooming on technologies, of course, because that's important for mobility management, with a range of presentations from all over the world, I have to say. And I take this opportunity to thank all our speakers, those present here in Amsterdam and those who are connecting with us on remote. And then we will zoom into materials, tools, and techniques for that, for sustainable roads. So we are going back to our traditional business, but again, try to challenge you and bring to you some examples on how things can be done differently. We will close this by launching our committee. Actually, this workshop is not only, we're meeting today not only because we are in the settings of Intertraffic Amsterdam, but it's also an opportunity for us to mark the launch of a new IRF committee on innovation. Without further ado, I think I would more invest the time I would prefer to leave time to our speakers and make sure that they have enough time to tell you all the interesting things that they have to tell. So let me immediately transit you to the first part of our session today. And let me introduce to you Mike Evans, who's the Global Highways lead at Arup. And he, as I said, is going to set the stage of this conversation together with George Yanis, who's a professor at the National Technical University of Athens. And we are very pleased to have them in our membership as well. So without further ado, I'll ask Agostina to help me translate this and pass the floor to Mike. Thank you.
So good afternoon, everybody. Thank you, Susanna. I'm really delighted to be here to talk about sustainability and innovation. So just to start off, we know we need to change what our road networks look like in our transport networks. Why? We've got a problem with emissions, we've got a problem with excessive consumption of resources, and actually our road networks and our street networks aren't giving us what we want. We've poor outcomes. And we need to do this change in the context that there's an enormous amount of change, new technology coming our way. So we need to harness this innovation. We need to do it really well. So what are we trying to do? We're trying to move from a set from our traditional way, a narrow focus on performance, thinking about speed, free flow, vehicle safety, and economic rate of return, to a much more balanced set of outcomes. And for me, I like to say that as we're trying to move towards balancing outcomes for society and outcomes for the planet. They're the outcomes that we want to focus on. So when we talk about these balanced outcomes, we talk about sustainable transport, we tend to, in our minds, jump to things like active travel and public transport and trains. And yet we absolutely need to design in more active travel on our roads and street networks. We have to think about the fact that we still will have freight that is going to have to move around our road. We've got road-based public transport, and we're going to have journeys that are only capable of taking place in a car. So we have to think about how we innovate to make all of this work well. So for me, for vehicle manufacturers, it often strikes me that for them, it's all about the vehicle business model. They're going to make it much easier for us to travel, make it more convenient for us to travel in cars. The innovation is things like driverless, different mobility services, different propulsion systems is also going to make travel cheaper. That's going to drive up travel consumption. And how do we manage demand? So for me, I like to think we need to think about innovation across all aspects of transport. We need to think about how we avoid traveling. So this innovation of how we do a Zoom meeting means some of us didn't have to travel today. That reduces demand. Having cities that are well designed so we can walk and cycle to our destination is another way of doing it. And actually things like road user charging, parking charging, they're managed demand as well. And then we think about how we shifting to more environmentally friendly modes of transport. And then we do the thinking about how we do the vehicle propulsion system at the end of that. So I would just want to delve into just rethinking how we think about transport. So designing a sustainable transport network requires us to think about the user, think about how they make trips, what they're trying to do as they make their trips. And we sometimes in IRF, we call this outcome-led design. We're trying to think about the outcomes of what the user wants to do. So just think about this for a minute. Think about how we can innovate across the whole aspect of somebody making a trip, because transport is about the trips that people want to make. So if you think about somebody who, is working, is a parent, when they're making their journey on their way to work, they have to make several components of their journey. Their journey will include bringing their child to creche or to school. Maybe it involves picking up a coffee, a newspaper on the way. And technology can enable people to plan their trips in a much better way. So we have information on our phones now about congestion. And when you think about it, we don't travel the same way every day. We adapt what we do depending on the circumstances of that day, what's going on in our lives, what's going on the transport network. We need to think about how we can make those trips more convenient. We need to think about everybody. So I'm a middle-class, middle-aged man. I need to not think about myself when I'm designing transport. We need to think about older people. We need to think about genders, different backgrounds of people. We need to think about all of the trips for all of the users all of the time. So let's just think about how we join a little bit of all of that, thinking about the trips that our people are making, and let's innovate how they're going to do their trips. This is a simple concept that we've developed with GoBus in the UK. It's about a future mobility hub. It's about how do we put things on our road networks that make it easier and more convenient to use public transport. So it's not just the public transport that we need to design for. It's all the ancillary facilities that people need as they make their trips. They need to be able to cycle to the location. Not everybody can cycle, so there's going to need to be some amount of convenient parking. You need some facilities where you can pick up that coffee as you get on the bus. And these are not just urban solutions. These also need to facilitate people who are making trips from rural locations into cities. So just, if you need to make this digital design, let's break it down into its components, make it easy to assemble, easy to manufacture so that we can roll it out quickly. And what happens is we apply this gradually. If we do this well, over time, we design out cars off our road systems, and then we can do better things in our road and street networks with that space. I want to think about a little bit about, the difference between what private car design does for a road engineer and how you design public transport. there tends to be a separation between the people who design our national road networks and the people who design our public transport. But what we actually need is we need more public transport on our road networks. So our road engineers are going to have to think like public transport engineers. And in public transport, we think about how we change mode, the interchange effect. We need our road engineers, people like me, to think like that as well. And that's about how you bring the road onto the public transport network. I'm going to tease this out a little bit more. So this involves us rethinking how we think about people moving. So when I spoke about the different types of people who are making trips and how they use the networks, that's a different way to think about traveling. It involves us modeling things in a different way. Our existing modeling systems tend to think that people make the same trip in the same way every day. That's not what actually people do. So we've developed techniques like agent-based modeling, where we make a synthetic population in the model. We allow the population in the model to change their behavior through the day. And this is going to give us the ability to predict that people will make different journeys at different times of the day using different modes, different routes. And that, if we do it well enough and iterate it enough, makes us better able to predict what's happening. We want to be able to make decisions based on individuals, how they actually behave, which that evolves over time. It doesn't always follow a regular pattern. So what I would like to do now is just kind of bring this thinking and bring it onto a road network. So I'm going to go through, I've got 6 themes I'm just going to work through as we do this. I forgot to say, a lot of this thinking, if you go on our website, you'll see all this material on our website at irf.com. So you're beginning to hear me talk about thinking about our road network as a multimodal platform. It's a multimodal platform, and that allows us to deliver sustainable mobility. We need to innovate the way we think about our road networks to achieve that. So rather than thinking as a road network as something that is just for one mode and the trip is completed in one mode, for example, a car, we need to think about people changing their modes as they complete their trip. So we can begin to imagine that people will drive to the edge of the city, change mode onto more sustainable modes, more convenient modes to travel into the city. So we actually have to allow for the interchange between the car and the train system, as you see on this graphic. And we need to think that maybe actually people will be cycling to these locations. How do we actually think about that? Let's go a step further. So transport network is part of a transport system, and the transport system is part of a system of systems. So there's another concept we can think about is the land use story. Our road networks take up a massive amount of land, and maybe we can use those that resource for more than just the road network, for more than just the transport system. This is thinking about how we bring ecosystem services into our thinking. How do we design that in? How can we maybe use all that road network that we have for biodiversity net gain? You know, our road networks would have removed biodiversity when they would have been constructed, and there's an opportunity to begin to do a bit of regenerative design, try and put back into our environment some of the things that we've taken out of it. The example I show here on the screen is where we've used the road corridor as a linear network. It is an ecological corridor for flora and fauna. We reconnect it with other ecological corridors, and it becomes part of a, if you like, a refuge within an intensely managed landscape. Let's just take that a bit further. So we know we need to reduce emissions from transport. We also need to manage the carbon that's used in the operation, maintenance, and construction of our road networks. This is where we bring in the innovation that we can think about how we apply the circular economy in detail. So a couple of concepts that are worth just thinking about here. You know, we need to maintain what we have. We need to make sure that we carefully retain the value. Cost a lot of money to construct our road networks. We need to retain that value. We need to optimize what we already have. And it's only then when we've gone through and maintained, optimized, do we get to think about building new networks. Maybe we don't need to build anything in the first place. And you know, the circular economy begins at R0 or R1, where you can retain what you have, rethink what you're doing, and maybe you don't need to build anything in the first place. A great example here locally that the team in Amsterdam worked here on the Netherlands, which is the Van Bernard Bridge, where what we actually did is in the refurbishment of that bridge, one of the arches, we removed the arch, took it away and completely refurbished it and put it back into place for a new life. And that involves a lot of innovation. In this case, it's the analytical techniques, the digital analytical techniques that we use to analyze the bridge. Just, you know, thinking a little bit further into the circular economy, what's that going to look like in practice? What I've done here is I've taken Stuart Brand's concept of shearing layers in terms of thinking about building design and applied it to road construction. Begin to think about, you know, as engineers, sometimes we have an obsession about designing for durability. Maybe we need to think about the fact that not everything lasts forever. We have some things that don't last particularly long, and we need to think about how those components of what we're building will be deliberately reused, recycled, repurposed in their components. So if you take the asphalt layer, the upper layers need to be deliberately designed that they can be reincorporated into asphalt for a second life, maybe a third life. We need to put the components that we know will be replaced in places that they can easily be taken out, replaced, and not require components that are more durable to be broken out. And there are other components to that. What I'm beginning to talk about there is designing for disassembly. We need to do life cycle analysis on what we're designing and providing so that we come up with the right decision, both in terms of its reusability, but also of its cost and the management of the material. And so our systems will become closed material systems. We need to have an awful lot more innovation in the type of material that we use. We need to think about how we're tracking the materials that we're putting onto the network, how we have digital material passports so that we know what we're dealing with. And that brings us into the innovation in terms of how we do our asset management, building information management, so that we have digital twins so we can optimize how all of this works. So another thing we can talk about, I've gone a bit over time. So we need to design for low emission vehicles. We need to not just think that having low emission vehicles will solve the problem. We need to make sure that we focus on reducing the amount of travel, that we have clean air zones, and that we enable people across all economic circumstances to avail of this technology. I want to just briefly mention, you know, thinking about systems thinking, the systems of systems in terms of ecosystems, but that also applies to the energy system. Our transport system is going to interact in a much more particular way with the energy system, and we need to think about how our transport system can deliver innovation for the energy system as well. Technology, digital, we all understand that how we plan our journeys is going to improve, how we use connected autonomous vehicles is going to improve what we do. Apps are going to make it easier for us all to travel. We need to think about, leave you with one final thought. We need to think about how we actually use that technology to take away transport, if you like. This is a piece of work we did in Singapore. You know, I'm talking about autonomous vehicles, trying to think about how we shift away the innovation from thinking about the innovation in the vehicle to the innovation of the use of the space, and using the autonomous vehicle as an opportunity to take away the space that's allocated to cars so it can actually be used for active mobility, regenerative design, climate change resilience. And listen, thanks very much for listening to me, and best of luck to the rest of the speakers.
Thank you very much, Mike. I'd like now to pass the floor and introduce George Yannis. Pass him the floor. George will be stressing the importance of data in all what Mike has just presented. George, the floor is yours. Thank you. And welcome to all the people who are watching from all over the world, actually. Thank you.
Perfect. So good afternoon, everybody. Thank you for this opportunity. And today we're going to explore a little bit deeper the interrelationship between big data, artificial intelligence, and sustainable and innovative roads. We are approaching the perfect technology solutions also in presentations. However, in fact, big data and technology, we have to decode them. They are everywhere, more and more, but still in a lot of places that there are open issues, let's say it. And of course, more open issues concerning the future of connected, automated vehicles, traffic, and transport. In fact, the road infrastructure scope is changing, bearing loads, opening pathways, but also as networks of communication, information and data collection, potential energy sources, in parallel with the main activities. And we're going to explore how technology and new and big data lead to more smart, green, efficient, safe, and resilient transport. In fact, smart roads and adaptive infrastructure are supposed to be dynamic, adaptable, and at least partially automated, still requiring human intervention. We're talking about smart intersections with traffic signal optimization, smart lighting, smart road maintenance. We also talk about dedicated lanes for connected and automated vehicles, optimizing on-street parking, green light optimal speed advisory, road use pricing, and there are quite a few impacts at different levels. Direct impacts on the road user, on the authorities and the operators, systemic impacts within the transport system boundaries like modal split, and of course, wider impacts exceeding transport system boundaries with emissions, with health, with every sector. So we need to estimate and anticipate these impacts. In terms of smart motorways, they are expanding quickly, not never as quickly as we wish. There is mandatory speed control, automatic signal setting, and speed enforcement using automatic camera technology, which are more and more present in smart motorways. There are significant gains, potential significant gains in environmental impacts in order to upscale traffic volumes, platooning, and their percentages of use. However, smart motorways have not yet improved road safety uniformly, and quite an important percentage of drivers are not even aware of the new traffic safety and environmental potential of new systems. The key challenges for smart roads, of course, is open and big data. The silo effect today hinders data sharing due to privacy, legal liability, intellectual property, competition, cybersecurity, and cost-related issues, and we have to overcome them. We need a smart solution with systematic resilience, scalability, timelessness, and interoperability. Artificial intelligence has to be explainable and fair in order to fully exploit big data. And policymakers have to develop digital skills themselves in parallel with the progress of technology. Of course, multidimensionality of smart road transition is evident to align with the UN SDGs. In fact, on one hand, we wish to have smart, safe, and sustainable roads, but first we have to work even harder and deeper in big data and artificial intelligence. The key big data contribution concern real-time or nearly near-time problem detection and customized decision support on every level. And this big data can support proactive assessment of interventions, either overall or with emphasis on safety, mobility, and environment. Big data can provide quantified feedback to support choices of both the user and the authorities. And big data can drive innovation, allowing more infrastructure elements and devices to be meaningfully connected through Internet of Things and cover additional aspects of transport networks in an integrated way. And of course, big data can provide a better understanding of rare events, not possible so far, especially those related to road crashes, not forgetting other special rare events on the road like weather, extreme conditions, etc. However, big data must be given context and purpose, something that we often forget. We have big data specialists, which don't know the subject. And we look where the data are and not where the problems are. There is a need for full analyst contextual knowledge in order to keep up with the specific developments and the ethical dimension. So we have to first define what we're looking for and what to use, and not vice versa. What we're using is not what we really need. An issue of complete absence of parameters and coverage of the areas of interest cannot be, of course, circumvented by data imputation, because we arrive to bias results and conclusions. And big data operations cannot be fully automated, as many transport aspects change constantly. There is new micromobility issues, e-scooters. So we have to keep up evolving with human intervention. And big data cannot encourage engagement or awareness of citizens if not fully supported by communication channels and applications. And it's true that studies demonstrate that when we're talking about big data and artificial intelligence, the perception level of the travelers is quite low, if not very low. In terms of consequences of data which are not always representative of the whole population, we have bias towards some user groups, and especially the groups which are using technology. So we always have conclusions about not the population, but our technology population, technology aware population. So we have to scale up our results to the whole population with special studies, automatic studies in one day. And it is easy to wrongly consider a data set as unbiased if it covers a specific dimension in detail, different road users, and forgetting some other groups, especially the modal split and exposure. We are talking too much about vehicles and too little about pedestrians and cyclists. We miss the real full picture. And the desired conclusion should not drive the research approach or outcome, especially when selecting features for analysis. This is an issue that there is a high risk for decision makers to be misled by the opportunistic analysis of seemingly low-cost data in absence of qualified data scientists and statisticians and the related data. So again, we look very often where the problems are, where our needs are, but not where we look at the data and not where our problems and needs are. In terms of key recommendations, we can say that there is need for road practitioners to gain experience by copying best practice from other sectors. Need for more secure alternatives to data exchange, as the exchange of structured queries and responses instead of raw information, which is much more meaningless than a structured data approach. And of course, multiple criteria-based exploration and decision analysis to determine the most efficient KPIs that can be mined or obtained in priority from the available big data. So we need contextual input and analysis. And of course, we need establishment of data harmonization and fusion protocols, investigating the best approach to reconcile different data scales from city to country to globally. On a high level, governments and road safety authorities should mandate the sharing of aggregate vehicle data, a key issue which still a lot to be done. Define a minimum data set for all vehicle manufacturers to report in an anonymous standard aggregate format, and end up these silos of too much data not available, not open. Collect data on traffic volume, speed distribution, and locations where vehicles' active safety systems are deployed. Clarify the regulatory frameworks for data protection and of course, go hand in hand data protection and deployment. And governments should also examine how freedom of information laws articulate with data protection laws. In conclusion, innovative solutions are ready today to reduce emissions, delay times, crashes and casualties, energy consumption, and other key indicators, and sometimes all this together. But still, we have to face the main barriers of data flow and sharing, transport system robustness and scalability, and artificial intelligence fairness and equality. Fairness and equality refers to what we produce. It is explained to everybody, understood by everybody, and without bias at any level. We need cross-discipline cooperation and increased familiarity with new technologies in order to overcome these multidimensional challenges. And big data applications are, you can say, that are powerful emerging tools that, however, need constant steering and attention by the users, by the authorities, by the industry to yield the desired outcomes. And with this, I conclude, and I'm very happy to continue the discussion. Thank you very much.
Thank you so much, George. Let me introduce myself. I'm Gonzalo Caraz from the International Road Federation, and I'm the Deputy Director General. For those that are asking online, all presentations and the recording will be published in our website. And if you have any questions, just please use the Q&A functionality on Zoom. We will try to address some questions at the end of the meeting. Right now, we're going to move to the second part of the workshop. We're going to talk about more on the technology side, so innovative technologies for mobility management. We will have 3 speakers. Unfortunately, Martin just got a very bad flu this morning and had to come back to Austria. So unfortunately, we won't hear from him. But still, we have 3 amazing speakers. So I look forward to this part of the meeting. And let's start with the first one. It's Gumada Murthy. He's connecting from Washington, D.C. in the United States. He's the Program Director, Transport System Operations at AASHTO. So he's going to tell us a little bit about transportation system management and operation and some trends that are affecting this line of work. So Gumada, now I leave the floor to you, and thank for being with us this morning for you and this afternoon for us.
Good morning and from Washington, D.C., and good afternoon to you all. Thank you, Gonzalo, and thanks for this opportunity for AASHTO to present our overview of our program, particularly for sustainable mobility. Anything in the mobility context, AASHTO looks at it as a transportation systems management and operations, a comprehensive, all modes, all networks in an equitable and inclusive manner. So that's the focus on the TSMO, Transportation Systems Management Operations. Next slide, please. So we are basically an association like IRF provides services to all our State Department of Transportation members. All the 50 plus 2 provinces of the states of United States are our members. Their CEOs are our board members, and all their transportation professionals are in various committees in our 150 plus committee network of work services we provide to our stakeholders. So in that context, we have established 3 service pillars to cater the transportation system management operations program support services to our stakeholders and members. If you go to the next slide, this is a graphic just to show you a high-level technical service programs. One of them is National Operations Center for Excellence, NOCOE. If you just Google NOCOE, you should be able to get it immediately. If you can go to that website, you will see all the other service pillars, including the Regional Operations Forum and also the Transportation Operations Manual that is being developed. This is one of the key slides. I want to focus on this for a minute. If you look at this, the technology applications, emerging technologies and strategies are on the left side of the slide. And all the TSMO strategies are listed on the right side. And if you can see the crosswalk between the strategies and the technologies would definitely provide you the alignment you need. I know in the opening statement, Susanna mentioned, and many others have mentioned in their remarks in the last 2 speakers, it's important that a technology connects to a use case. And that's where the applications are coming in. So I'm not going to labor on the very popular applications you always see these. These must be happening even before technology evolved. We have managed work zones, we have managed weather programs, we have tried to avoid signal delays for many emergency vehicles and transit services. But how do we enhance them in an equitable manner to all networks, all modes, so that the technology does not come for the technology's sake? It connects with the strategies. So that is the takeaway for me. If you want to sustain mobility, you need to make sure that the strategies are in place. They are the driving engine to implement the technology and for the benefit of the network and for the benefit of the users. If you go to the next slide. Now, this is another important thing is we have currently working on these key use cases. For example, AV applications in the work zones is one of our prominent use case that we are looking at it. And some of the TISMO use cases that are becoming very popular, the smart weather information systems. I already talked about the work zones and the connected and AV vehicles, but also the red light warning, the arterial operations on the red light warning, reduced speed zone warnings, and the corridors. If you connect the corridors with the technology, basically modernizing the signal control cabinets and making sure that the signal operations are efficient is one of our top use cases, including the lane departure, which is for arterials and as well as interstate systems. The multimodal intelligent signal system includes transit signal preemption, but also connecting with other modes like metro and light rail and heavy rail, and making sure that those intersection points are well covered. If you go to the next slide. One of the speakers brought up on the outputs and outcomes. I'll speak to that in a minute, but one of the important things we have come around is the decision support system. One of the major TISMO initiatives was Integral Corridor Management, ICM systems. And in that context, the DSS system that was an outcome of that initiative has become kind of a sustainable model to make sure that any TISMO strategy that is implemented will have an actionable decision support system built around it. If it is a weather program, or if it is incident management, or if it is congestion pricing, what is the transportation decision that comes out of those implementation efforts that will help to manage the system in a timely manner, in a responsive manner? So that is one of the key things that we are looking at, to also implement an artificial intelligence approach. The predictive algorithms that go into the DSS would make it more robust and more modernized to accommodate the emerging technologies into the program applications. And then how does it impact the workforce? Do we have the level of skill set available in the workforce to absorb the emerging technologies and to accommodate these latest innovations into the program? Go to the next slide, please. So this is another big paradigm shift we are experiencing in our stakeholders. There were outputs, data-rich information pool. We have talked about that in the past. Information-rich data pool. Sometimes there is more data, but there's no information out of that. Now, in the similar context, we are looking at it. Are we just focusing on outputs? Are we just not focusing on outcomes? If you implement a strategy, if you implement a congestion pricing strategy or active traffic management strategy, besides the strategy itself is clicking and all technologies are working, giving the desired measures we want to get out of that. For example, reduction in delay, increase in congestion pricing gave us enough balancing on the traffic volumes on the general purpose lanes and the Lexus lanes or the toll lanes. But is it really helping the user to achieve the end product of the mobility? That he reached on the destination, he was able to connect with the first mile, last mile services efficiently. There is safety. If you make a good weather prediction, is it trickling down into shifting the peak hour from the weather event to a non-weather peak hour? So those are the outcomes that are important to measure. And that's where we are focusing on how the earlier slides that I've presented to you, the strategies, the technology implementations will ultimately connect back to the outcomes. The next slide, please. So to accommodate all these discussions, we have also embarked upon generating a transportation operations manual. This research work has been in the works for the last 24 months. And this year, we are nearing completion on completing the manual, balloting within our AASHTO committees and adopting that manual by end of this year, and probably release it by TRB 2023. So this is our major flagship project this year. And this would connect with all the earlier strategies, outcomes, and technology implementations I was talking about. And we will be happy to share this as it becomes available to this new committee that is being launched today, which would be, I'm sure, would be very interested in interacting with our AASHTO committees and as well as this manual. The last slide, please. These are the chapters, and these chapters, the names of those itself would speak to the depth and the volume they are supposed to address. And again, this is as much as parallel to the Green Book. The AASHTO Green Book is very popular in the design context. At the same time, it is the beginning step. This manual is of one of its kind right now within our AASHTO publications and also the worldwide comparative publications we have in this TISMO category. And the starting step is expected to add more companion documents to this and make it more robust and available on a digital version mainly. And we'll take more input from the industry trends and complete it in the future coming years as a long-standing available service tool for our TISMO communities within the United States and outside as well. So those are my takeaway points on this, and thanks for the opportunity, and I'm here for any questions.
Thanks a lot, Kumara, for being with us this morning for you. I wish you a great day there in Washington. And yeah, I look forward to work on you with this new committee we're launching. We have already cooperated with AASHTO on the committee that we have on connected and autonomous mobility. So we are definitely continuing on that line of work. Let me just move now to the second speaker of the session, which is Christoph Berdot. He's head of rest of world for Svarco, coming from Germany, and he's going to show us some examples, use cases of implementations of their solutions around the world. So I look forward to hear more from you, Chris.
Yeah, thank you very much. Yeah, thank you for the opportunity to give you some insight in our connected, intelligent transportation systems use cases in smart mobility. We at Svarco are more and more focusing on use cases, business models, and not so much more anymore on technology. Technology is in the cloud. Cloud means OPEX, CAPEX, variable cost, fixed cost. So cloud is variable costs. And we host the systems on Google, Microsoft, or Amazon clouds, and in a hybrid form that the data is hosted in the country and the platform is hosted globally or on-prem. And we use these use cases to create business models out of it, reduce KPIs for the cities, we will see in a minute. So for example, CO2 reduction or accident reduction, classical KPIs a city want to improve. The first one I show you is our traffic signal service. It's actually planning, simulation, and testing tool called LISA, Lichtsignalanlagensteuerung on German, typical German long word. It's one word. But the benefit is here, it's digitalizing on one hand the planning and the configuration in the field of the controller. So the traffic engineer can use this tool to plan an intersection with left and right lines straight on, bus lines, tram lines in the city. And as he's configuring it, he can also configure the signals and then configure the structure remotely on the controller in the field. This is a real digitalization of the process of planning and configuration and helps, for example, to reduce the CO2 costs if you don't need to send a service team to each controller in the city to reconfigure the controller in the field, the roadside unit. So a clear benefit. This tool is starting at the university. Traffic engineers are learning with it how to plan and configure a traffic system in a city. Cities are using it as well as consulting companies. And it's really a digital tool. We use it a lot in Germany as well as rest of the world. The next use case is the public transport priority. Here we have a real-time communication between the bus or the tram with the traffic signals. This helps a lot to improve the customer journey of the people who uses the bus, as we have a better consistency on the schedule of the buses. They are better in time. They are also the CO2 reduction is also an argument here. And we can also scale this over different intersections into a corridor. A similar from the same technology use case is the emergency priority. Everybody knows the congestion spillback when there is an alarm of an emergency vehicle and everybody drives on the intersection and stops and the vehicle tries to get through the emergency vehicle. And here with a real-time connection to the traffic signal and the intersection, we can directly manage the traffic as well as a corridor that the emergency vehicle has a safer come through to the intersection. It's a low cost and quick deployment solution. The traffic light forecast is another one. We provide this information not only in the car, in the dashboard, as you see here, also on a mobile phone. So you can use it as a bicycle cyclist on the bicycle and see if I drive 2022 or 18, I get the next green line and don't need to stop. Same for the cars. So you don't have this pressure to don't know, can I make the green? And it relaxes the driver heavily and is also improving the traffic flow in general. The next one is the Roadworks and hazard warnings. With an in-vehicle information plus on the variable message sign as well as the mobile variable message sign we see here on the picture. We take environmental sensors and cameras from with accident information or with slippery oil or other incidents, and then we can smartly manage the roads from 3 to 1 road to help to reduce shockwave traffic jams. And another example is hard shoulders, emergency line management in a smart way, and helps to keep the traffic again smooth. Another very nice one is the vulnerable road user use case. Here we think about bicycles at an intersection with trucks, which are going on the right. And sometimes they have a black spot and can't see the bicycles. And then we have a bad accident. And here we can analyze with cameras if there's a bicycle and a truck in a critical situation. And we can, for example, give the truck driver 6 seconds longer red to secure the crossing of the cyclist over the intersection, as an example. This reduces bicycle accidents in the city heavily. Another one is also for pedestrians. Then we have the, so to say, heat map of the real-time traffic data coming from different sensors and car communication, which helps us to see exactly what's happening in the city, where are the traffic jams, etc. And then we can directly improve our traffic management through this in a specific way. The last one is the data broker service. We have a complete analytics of the intersections with data about pedestrians, cyclists, cars, trucks, peak times, trams, etc. And we can provide this in an open interface to the city or to third parties for other software as a service applications, also for startups interesting if they want to create special applications on it. And this is a very good data providing for any new use case in the future. And that's it already. Thank you very much. And if you have questions, I'm here. Thank you.
Thank you so much, Christoph, for being with us this afternoon. Now we are closing the second part of this workshop with the last speaker. He's Michael Bardi from the UK. He's the Chief Business Officer of Valeran. You might know this. Valeran is one of the recent winners of the IRF startup label. So I congratulate again the team, and I look forward to hear from you on what solution you are bringing to the market.
Hey, everybody. Hello back home. So I'm Michael. I'm one of the co-founders of Valeran. About 3 months ago, I was in a big control center back in Israel. There was many screens, about 6 different people sitting in different laptops, looking at what's happening on the road. All of a sudden, there's a massive alarm. Okay, this was 2 alarms. There's one big flashing red light, and at the same time, there was an actual fire-style alarm going off. Okay, someone out there, for some system out there, was saying there's an accident on your road. You have to act right now, and everybody just sat there, ignoring it. Now, this is something that for those of you who have been in a control center of a road, this might sound familiar. Almost every single control center I've been to, there's been a big flashing red light that everybody ignores. And the reason everybody ignores it is because they don't trust it. And building on what George Yanis just said, I want to talk about big data today and about one of the fundamental problems that we see in it, which is to do with trust. So a bit about, don't know which direction. Nice, thank you. Okay, great. So a bit about Valeran. So we're a startup, we're an AI company that helps road operators trust their data and act upon it. We've been around since 2016. We're now operating in 4 different countries, and we've raised $25 million to date to build what you're gonna, or some of what you're gonna see today, other things I won't have time to show you. At high level, what we're trying to do is we're trying to empower road operators through data. And what that means for us, it means we're trying to help them trust the data that they have. We want to give them certainty in the decisions they make based on that data. And then we want to empower them to actually be able to carry out those decisions. So when I say there's a problem with trust, what do I mean? Well, so there's no lack of data, right? You have cameras, you have connected vehicles, you have navigation apps, you have radars, you have open weather stations, you have everything. And despite all this data that we have on one side, ultimately, almost every single road operator that we worked with uses phone calls to detect accidents, uses cameras to verify them manually, and then uses patrol to react. Now, this gap between the amount of data that we have and the tools that we use is a gap of trust. Is I get this information, but I don't want to act upon it immediately. I want to make sure, I want to double check, I want to verify. And this has massive consequences because it means that we act slower. It means that we're not as effective. It means we're not as precise as we could otherwise be. What Valeran do is we try to build that trust, and we try to build that trust really, and then empower you in 3 phases. The first thing is we make sure you have all the data you need to see what's happening throughout your road. So we bring all the data into one place. I mean, this is quite standard. This is what we call integration. Integrate your cameras, your loops, your radars, your connected vehicles, your navigation apps, your open weather stations, whatever you need into one place. But then the important thing we do with that is we fuse it together, go beyond integration into fusion. And what that means is that we're able to precisely tell you that that thing you saw from Waze is the same thing you see in the camera. And that congestion you see from your loop, that is caused by that thing that you saw in the camera. Now, bringing that together, that makes now, instead of having 3 different events that are coming from 3 different sources, now you have one event with 3 different events verifying it. That is very different because now you have trust in that data, you have trust in that system. And now that you have that trust, you can do the third thing, which is act. And we do 2 things. First of all, we connect you with the different sources you have to act upon that, your VMS, your Waze, your Google Maps, your TomToms, so you can reach out to your customers. But we also provide you a tool to create rule-based response. I won't say automation because that's a bit far in the future, but rule-based, if this happens, then that. There's some things you can do like that. You don't need to wait for someone to get there to look at it, to know that, you know what, I might as well slow down the traffic. I might as well just send someone to look. There's some things you can already do. I should send an alarm on Waze because there's probably an accident there. I might as well do that now and not wait. So what I'm going to do now is I'm going to show you a few examples of how that looks like from the technical side and from the user side before I summarize. So one sneak peek is how we use it on cameras. Cameras are very challenging because you might have cameras, but first of all, they're in what we call the XY space. They're a big square, and what you see in a camera is very hard to transpose to what you see on a map because that's the coordinate space. And if you have PTZ, it's doubly challenging. You don't even know where it looks at. So what we've created is we've created a system that automatically detects exactly where the camera is looking at and transposes the system perfectly onto your map. And what that means that when you see, and this is basically a capture of a live road, what you see is that when you see now a car in your camera, you now see it actually driving along your road precisely. Now, the reason that's important is that now when you have that Waze event in a specific coordinate system, you're able to know that, oh, that's the same thing I see from my camera. Here you see this transposed, by the way, on a satellite image showing you how precise this automated process is. And so now if I have an instant detected here, and then I have down the road, I have congestion from a loop, and then I have Waze coming up, all this is interrelated on the same coordinate system. And that is now why I'm able to trust it better. That's just one example. We could talk about radar, we could talk about connected vehicles, but later. So this can be even provided, if you have your own ATMS system, this can be provided as a module within an ATMS system. What we found is a lot of roads have nothing because a lot of systems are too expensive. And so for those who have little ITS, we provide our own web-based application. So this is Lantern by Valoran. Here we bring all the data sources together. And for example, if you have an alert, let's say Waze says there's a stopped vehicle detected, we provide you the alert, its location. Then we show you the closest camera. We give you both a video capture of that event. So those 2 minutes, you see the vehicle that is actually as it's stopping, because we kind of assess when that more or less happened and where. And then we also connect you to your live camera at the same time. So you can say, oh, is it actually happening? It's not. Then, connect you either to Waze, to Google Maps, to your internal systems, to Slack, to email, to your emergency response, whatever you need. They can also have access to this if they want to see it. Say emergency response, here, take a video so you can see what you're going towards. And then at the end of all of this, also, if you want, connect your patrol or anything like this. So again, improving your connectivity, improving your certainty, and allowing you to actually react faster, more relevantly, more effectively to what's happening on your road. So in summary, so Valoran and Lantern by Valoran, what we just saw, we want to help road operators increase safety, reduce congestion, save also costs, and engage the users on your road, help keep them more informed. We do that by facilitating trust in the data that you already have. And what that means, it means that you can reduce the response time to accidents. It means you can identify and react to bottlenecks sooner. You can start leveraging ITS with the reduced cost without the amount of CapEx, as my colleague said before, and also communicate directly with your drivers. So you actually have a more, say, a wider relationship and a more profound relationship with your users, with your constituency. So thank you very much. These are my details. If you have any question, or be happy to hang out later as well. Thank you.
Thank you so much. And I think it was a perfect conclusion for this session on technology. We've seen tools, we've seen the importance of data and the strategic thinking behind it. And that all together brings innovation in our sector. I think we're running slightly behind schedule. And so I'm gonna quickly introduce you the next round of the speakers. We're moving now into the session more specifically dedicated to materials, and the speakers that will follow will show you that actually there's lots of innovation also on a traditional segment of our sector, such as materials. So I'd like to welcome to, I'll read it from there, Paul O'Halloran, I hope I made that right, Research and Development Project Manager from the Holcim Innovation Center. We will then welcome Clarissa Hahn from Australia, the Australian Road Research Board. We'll go to the UK with the University of Birmingham. And then, and for those of you online, because I see lots of people from all over the world connected online, Meran will tell you also interesting things that are very relevant to low and middle income countries. And then we'll close that part, this session, with Sean from 3M, so a specific focus on safety as well. So I'll, without further ado, I'd like to pass the floor to Paul. We're all set. Thank you.
Many thanks, Susanna. It's a pleasure to be here today. First of all, I'd like to reiterate what Susanna said at the start about the sector being very traditional. If the sector is very traditional, certainly the concrete industry is, I'd say, even more traditional, more conservative. So I'm a firm believer that the industry needs to embrace and expedite the adaptation of digital technologies to enable us to build a more sustainable future. Just to share with you maybe a bit of a statistic, approximately 10 billion cubic meters of concrete are produced every year. So that equates to 320 cubic meters every second. So at the moment, we're not capturing any data from that. We're not capitalizing on any data from that. But I believe doing so will lead to efficiencies in how we use our materials, enabling us to provide even more sustainable solutions. So I'd like to share some fast facts about Holcim for anybody who's not aware, in terms of just a brief glimpse of the company and what we do in terms of innovation. So we're the world's global leader in building solutions. We've got over 70,000 employees based in over 70 countries globally. We have signed up for a net zero pledge, which is going to be validated by the Science Based Targets Initiative in 2030. In the ECG rankings by VE by Moody, we're in the top 2% globally with an A+1 rating. In terms of solutions, we plan to provide 1/3 of our sales in green solutions going forward. In terms of global R&D, perhaps I'll move on to the next slide to share what we do in terms of innovation and global R&D. So our main global R&D innovation center is based just outside of Lyon in France, where we've got a team of over 200 researchers based there. We've got over 1,500 active patents. We've got 6 innovation centers globally, and we've got multiple technical centers around the world. In addition to that, we've got strategic academic partnerships with over 40 universities, ranging from MIT, Cambridge, and to École de Paris. Additionally, we also go down the route of open innovation. So we've got a separate entity within Holcim called Maker, which focuses on startups and predominantly a lot of digital startups. We arrange different hackathons. We arrange the Holcim Accelerator. So without further ado, I'd like to share with you specifically my project, the project I'm working on for Holcim at the moment. It's one of our top 10 global projects. The project itself is entitled Self-Testing Concrete. So what we'd like to do, it's a multifaceted project, but what we'd like to do is completely reimagine the ready-mix concrete process. And how do we do that from cradle to cradle, essentially? So in terms of raw materials, we're looking to develop blockchain similar to the food industry, with similar to digital twins as well. The ready-mix plants, we already have an initiative, which is cement plants of tomorrow. Now we're going to start a new initiative called the ready-mix plants of tomorrow, where we want to implement sensors, probes, tags at ready-mix plant level. To give you some examples of what we're planning to do, we're going to look at optical sensors to analyze raw materials as they enter a mixer. In addition to that, we'll link that to an advanced mix design software system, which will also incorporate predictive models, allowing us to adjust mix designs in real time, which will allow us to develop more sustainable and efficient products at the end of the day. In addition to that, we've got in-transit sensors. So how do we deliver our concrete to site? We've operated some POCs globally where we've placed sensors in trucks. We're looking at initial properties such as slump, air, and temperature. The benefit of this is that we can reduce truck movements, bring efficiencies in terms of sustainability and performance. And then further from that, we're looking at digital sensor technology, predominantly for concrete that we deliver. A lot of our sustainable solutions like EcoPact, which can reduce carbon by 30 to 70%. We are looking at various options, whether we implement physical sensors such as RFID passive sensors into concrete, or we look at digital traceability such as digital material passports. So when we provide our concrete to customers, they can clearly determine what the product is that has been provided. If you go to checking it in 100 years time, 150 years time, it allows full traceability and allows it to enter the circular economy a lot easier and a lot quicker. So what are we doing today and what are we planning to do this year? We're planning to launch the first in a series of digital value-added solutions. So we've been working on a combination of experimental tools with URLs, an example of which is our thermal tool. So it's a finite thermal analysis tool that works in incorporation with an experimental tool called Holcim Heat to determine the thermal fingerprint of concrete. The benefit of this is for risk mitigation for customers in terms of mass elements and finite modeling for mass elements. In addition to that, we're looking at pump simulation tools. So it allows us to simulate how far we can pump our concrete whether that's vertically or horizontally. The benefit from that is, again, risk mitigation, but also reduces the requirement for customers to undertake costly and wasteful pump trials. And then finally, we've got maturity. So in terms of maturity, we're looking at maturity sensors. So what are maturity sensors in concrete? Essentially, it enables our customers to see digitally what the compressive strength is of concrete in real time. Once the customer can see the compressive strength of concrete in real time, it allows them to remove formwork more rapidly on site. And then I probably should loop back on the thermal tool. Some beneficial examples of that, which we've seen, are in Australia, more recently with the Transport and Main Roads Authority in Queensland, where they've utilized this tool on a lot of major infrastructure projects. All these offerings will come under the acronym or the umbrella brand of iConcrete for the business. So I'd like to thank everybody for your time today. Have a nice day.
Thank you very much, Paul, for keeping within the time. So we are catching back on the slightly late. We're now moving to Clarissa Hahn. She's a National Leader of Sustainability and Resilience from the Australian Research Board. She could not be presently with us online live because it's very late already in Australia. So she has pre-recorded her presentation. So kindly asking Agostina to show that. Yes. I would encourage everyone online as well to keep pushing forward your questions via the question and answer function. If we are not able to take all those questions today, because we have quite a number of them, we'll make sure we get back to you offline. We'll reach out after the event in the next couple of days back to you. Thank you.
Good afternoon, everyone. My name is Clarissa Hahn. I'm working for the Australian Road Research Board as a National Leader, Sustainability and Resilience. It is my great pleasure here to share some of our latest research initiatives and progress in innovative technologies and recycled materials for sustainable transport infrastructure. The Australian Road Research Board is an active member of IRF. As the Australian National Transport Research Organisation, we were set up in 1960. We were the centralized depository of independent expert transport knowledge, and we advise key decision makers on our nation's most important challenges. In our latest strategic plan, we have clearly defined our vision. It's an integrated mobility future, which is safe, sustainable, and a driver of economic well-being. The Australian Commonwealth Government is committed to the ongoing delivery of a record of 110 billion over 10 years infrastructure investment program to drive the economic road back from the pandemic, building the economy and providing certainty for business over the long term. While these investments will deliver economic and social benefits, the construction of transport infrastructure is resource intensive, requiring significant amount of natural, raw, and engineered materials. The government has highlighted the importance of recycled contents in these projects in the National Waste Policy Action Plan and recognized that incorporating those recycled materials and products can achieve significant benefits affecting the triple bottom line of those infrastructure construction. In this context, UP's role is to offer a wide range of research and engineering services to support the beneficial use of recycled materials. We conducted engineering performance evaluation of those recycled materials, make sure they are equivalent of conventional virgin materials, if not better. We investigating the short-term and long-term health, safety, and environmental impacts and requirements. We also look into the performance and recyclability of the materials at the end of the life to support the circular economy. On top of that, UP also offer a wide range of materials performance and certificate services, utilizing our national reference materials laboratories and facilities. We conduct new material assessment services, delivering comprehensive desktop feasibility analysis, implementing the laboratory trials, ad hoc testing, and full-scale engineering trials, also developing the specifications, guidelines, and technical reports. Some highlights of our recent deliverables or publications. From the national level, we developed the national guidelines, specifications, and the best practice advice. For example, late last year, we just published the national specification for crop rubber binders in asphalt and sales while off-roads. Early in 2022, we also developed and published the off-road specification for recycled crushed glass as a sand aggregate replacement. Ongoing, we're developing the best practice expert advice on the use of 10 recycled materials flows in the infrastructure for Commonwealth. At the state and territory level, we deliver the sustainable engineering solutions via our collaborative R&D programs with state road agencies. I have highlighted 2 programs here. One is NACO, the National Asset Center of Excellence, which is an initiative between ARB and the Queensland Department of Transport and Main Roads. Another one is WARUP, which is Western Australia Road Research Innovation Program. Again, an agreement between ARB and Main Roads Western Australia. Both program or agreement reflects a strategic commitment of road agencies to research and development, technology transfer, and capability development. Specifically, both of them provides quite substantial sustainability program and projects. Some of the classic projects ongoing are displayed on the website, which is publicly accessible. For example, investigating the use of recycled plastic in future sustainable road infrastructure, and the calculating and reducing greenhouse gas emission from the innovative pavement technologies. Further, at the local level, we're also actively involved in the field trials of utilizing the recycled products or contents to support the construction and maintenance of the local roads and the development of the specifications, fit for purpose specifications to support this really light traffic roads. In summary, ARB's research work covers a broad range of recycled materials, applications, assessments, trials, and implementation guidance for all states and territories across Australia and New Zealand. We also actively deliver assessment methodologies, frameworks, and tools to help the asset managers understand and quantify the impact associated with those applications. Along the journey, we have identified substantial sustainable benefits of utilizing these feasible recycled materials, such as reducing the amount of waste sent to landfill, reducing the greenhouse gas emission generated by the production of new materials, and reducing the reliance on the non-renewable and important resources, developing the circular economy in which materials are continuously reused in their highest and best usage, and creating new market, new jobs, and potentially improves asset durability and performance. I hope this provides a brief summary of what you are delivering in this innovative and exciting area. Feel free to get in touch if you have any further questions or inquiries. Thanks, everyone.
Thank you. And I would like to actually swap and give the floor to Sean from 3M. He's the Global Business Vice President for 3M in the United States. Sorry. They're trying also to catch up on the delayed. And we'll get back to Meran and the crisps in a few moments. Thank you.
Great. All right, so good morning, good afternoon, good evening to those on the line and around the world. My name is Sean Lowry. I am the Global Business Vice President for the Transportation Safety Division at 3M. And those who work in different time zones, I have an appreciation because I do work globally. So thank you for being on the line. So today I'd like to share a little bit about one of our modules. So we have a software package called the Safety Infrastructure Management Suite. And one of the modules in that is called the 3M Roadway Safety Asset Manager, or RSAM in terms of our acronyms. One of the things that we do at 3M in our division is we help bring families home safely. As you guys know, 1.3 million people die each year in road fatalities. And so we focus on safe infrastructure, safe solutions, software solutions to provide that. And so today I'll share kind of one software that kind of brings together some of the things we talked about today in terms of innovation, big data, connected automated vehicles, and kind of pulls it together in terms of an application of one application. And so for the software opportunity, there's kind of 4 trends in asset management of why it's more important now than ever, right? So one is aging roadways. So in many countries, in both developed and developing, we have aging roadways that need to be maintained. The second is, as many of our speakers have shared, there's lots of data available, and data collection is available for us. And the question is, how do we get that data and what do we do with it? The third is strained budgets. Most of the government agencies and officials and ministries I talked with around the world have pretty much fixed budgets with some exceptions. And so how do you maximize those strained budgets to replace assets so that they provide safety and provide value to the end users? And last is enhanced predictability. So how can you predict, in this case, what assets do you need to replace, when and how do you direct your maintenance teams? And so those are kind of 4 trends. All right, so here's some highlights for the Roadway Safety Asset Manager, right? So what does it actually do? So typically in a traditional like survey grades survey, you'd have a car driving around a city or a municipality, and the car would have some sort of a camera on it. And the camera may be what's called LiDAR, so light emitting detector and radar. It takes basically a 3D map of the assets. And they have all the information, and then someone would sort through it, capture that data and pinpoint that data to a GIS layer, so to an actual map. And then you have exactly where all the assets are. You have like the retroreflectivity for the signs, how reflective they are. You have the road presence for pavement markings. You have the utilities, and you know where everything is on the map. And then if the person drives that around, then you have all that data. And so what the software does is it brings that data into a user-friendly format to identify the assets, plan and track the assets, get rid of paper records. In many cases, many of our agencies have paper records today, Excel spreadsheets, paper records. In some cases, some of our agencies that I've talked to have actual students that actually walk around and drive around for a year to take a survey of their assets, and then making data-driven decisions. And so it's a cloud-based solution. It's mobile. We've had a version of this for about a decade. Now we have a more refreshed version that's now more user-friendly and helpful. And so another little anecdote is, so why is this important? So we talked to one of our agencies, and they want to improve lives. So they want to do a countermeasure. So they want to replace all the curve signs in their jurisdiction. Well, it took them 18 months to find out where all the curve signs were, to find out just where they were before they could replace them, right? So this helps you give direction to your maintenance teams of specifically what assets to do to maximize your budget. And then the question is for innovation technology linked to connected automated vehicles and big data, what are we doing now? So we have a collaboration with Mobileye. For those who are not familiar with Mobileye, it's now a subsidiary of, I think Intel purchased them, an Israeli company. They're great partners. And they have one of the sensors that's on the cars, and it's on probably more than 2/3 of all the cars have a Mobileye sensor on it. And that sensor is collecting data every day. So they have millions of cars around the world traveling, collecting all this data. And then the question is, again, what do you do with that data? So we're now mapping this data, and we're merging it into our Roadway Safety Asset Management software data, so we can do a GIS layering. So we get, instead of kind of a one-time survey like every year, we can now get that information real time. And so is less high quality data at a higher frequency good enough to make decisions and make predictive analytics? We think so. And so we're working on that now. And so our ask is, so we're working on this in the US now. We're looking for other pilots around the world as we roll this out and figure out how we maximize this opportunity with Mobileye. It's a great opportunity for us. And kind of in closing, so it's the last thing. So it's a software solution. We link to connected automated vehicles, because what do connected automated vehicles do, right? So connected vehicle means, right, it's connected to infrastructure, it's connected to the cloud. Automated means it runs by itself, right? And so on the automated part, it's reading pavement markings, it's reading signs to run by itself. And so how to make sure we have those assets as good as can be for safety purposes. And so this helps us replace those assets in a timely manner. So it's a comprehensive asset solution. It's good for, you can query data, you can figure out which assets you need to replace. You can send out to your maintenance crews. Maintenance crews can put the data information, they can record it, and it comes back, and it's all in one nice solution. And this is one of our modules kind of in our suite of solutions. So being one of the last speakers, I will stop there. So, so thank you.
You're actually not the last speaker. We still have, in this long, quick journey, we still have Meran Eskandari Torbagan. There I see Meran. Good afternoon, Meran. Thank you for joining us.
No problem, pleasure.
Lecturer in Infrastructure Asset Management at the University of Birmingham. And I'll immediately leave you the floor to talk about climate resilient, sustainable road, pavement surfacing, CRIPS. It's a project on which we are very pleased to support as well the University of Birmingham. Meran, with a kind request to keep your remarks within the time because we're running a little bit.
I will try. Yeah, I'll try to make it even shorter. No problem.
Thank you.
No problem. Thanks, Susanna. So this is the title of our research project. It's an ongoing research on material and 3 different types of material. Just going through the project now. A bit of background. The project is based on the findings from a previous project, and both projects funded by UK aid. And so the finding of the first part of the project was how could new ways of designing and building roads using new standards and marginal materials deliver low maintenance resilient roads economically. So based on that, we came up with all sorts of solution as part of to be trialed as part of this CRIS project. So the list of partners: Birmingham is leading, and Accra, New Zealand, UPM, Malaysia, and IRF is kindly putting everything together and as part of our dissemination activity. So it is an 18-month project. We have 3 types of material, which you can see on the screen: modified epoxy chip seals, modified epoxy asphalt surfaces, and fiber mastic asphalt. And the idea is to trial these 3 sort of surfacing technologies in Ethiopia. And we heard about new technologies and not having enough data. So we have data from New Zealand and Malaysia. So New Zealand, they have done a lot of projects, I think over 10 years, the same with Malaysia. So Ethiopia did the epoxy sort of trial. So we have data from New Zealand, and we have FMA, fiber mastic asphalt from Malaysia. So we got that data. Well, the project idea is, okay, can we use that data to rely on that data and in other countries, specifically low-income countries, and can we use those in there? And would they, how would be the performance compared to normal practices? That's the whole idea of this project. And you can see that in this sort of diagram methodology. Just briefly tell you, so we have developed deterioration models, and New Zealand team, they have done, they're sort of putting everything together. They got data from Malaysia, they have their own data from New Zealand. So the deterioration curve and deterioration models coming from these 2 sources. Then we applied the condition in Ethiopia, and the data that we got from Ethiopia, and the road condition data from their normal practices. And then we put those 2 together within the HTM4 model. So this is condition prediction model. HTM4, I don't know if you're familiar with it or not, just developed partially with by University of Birmingham and supported the World Bank. So using HTM4, we are developing now some different scenarios. And the idea is to model simulate the condition in Ethiopia using this tool. As part of the project and in parallel to these activities, we do quality assurance, quality control measures. And that's work stream 3 down there. I'll show you in next slide some of our fundings. And then we ship the materials. They supplied, epoxy is supplied by US, and fiber we are importing it from Malaysia. We are starting the trial very soon. So we have 3 different road sections and 1 control section, and to address that trial constructability of these technologies. And then IRF is helping us quite a lot in disseminating of activities. We have workshops and we try to engage with different stakeholders. So on the innovation part of it is to really showcase the constructability and practicality of these 3 technologies in low-income countries. Yes, they are working in New Zealand, but climate is different in New Zealand compared to many low-income countries. Traffic is different. and I was chatting with my friends, colleagues in New Zealand. They consider their sort of situations the low traffic, while the road section that we selected in Ethiopia, those are high volume transport, high volume roads. So that's part of the whole idea. Also to consider the climate change impact. So as part of our project, and I have to mention, as part of our partners of the project, ERA, Ethiopian Road Authority, is on board, and they have been quite supportive of our project. I'm very thankful we are for their support. We have a PhD student, and the PhD student has looked into climate change impacts on road Ethiopia and the road condition in Ethiopia. So that's what we did as part of calibrating HTM4 models to consider climate change impact on road surfaces, different materials. Life cycle analysis is there as part of the HTM4 model. And also on quality control QC on the right-hand side, you can see FTIR, which is infrared technology, and also so we did that, and you can see the result on the bottom of the page. So that's FTIR result versus the real mixes, and you can see a 99% accuracy. So FTIR is quite probably not the cheapest, but it is a reasonable price, and then it can be purchased and in low-income countries. But also we're trying to find out more simpler methods. But then more accurate sort of thing, this particular sample was quite high, and that's why probably I selected it. But anyway, we have more sort of complex methods, neutron beam particle, and our team in Birmingham, our physics department, are looking into that as well as a way of calibrating the FTIR, or to go alongside FTIR result. And then trialing this technology is another part of what we call innovation of this. Susanna, over to you. I hope it was on time.
Meran, you've done a fantastic job in even going faster than the allocated time.
I hope it wasn't too fast.
No, it was very clear, and I thank you very much for that.
Here they can see you.
Yes, I need to stop this. Maybe Yes, I don't know if you can see me on the screen. The logistics of this hybrid event are a little bit complicated. We are getting to the end of this workshop. I saw there are plenty of questions on the question answered, but in the interest of time, people have been having a very long day here at Intertraffic. We're going to make sure that we get back to you on offline and publish those answers directly. I just want to now take the opportunity to tell you that everything you have been hearing today in those presentations, it really gives you a bit of a sense of the work that this new IRF Innovation Committee we're launching today will be looking into. So the committees, of course, are reserved to our members and partners. And so make sure you reach out to us if you want to get involved in this new committee. Without further ado, I think I will close this here, but ask you to stay because we have a very special message and some wishes for the new committee from Matthew Baldwin, who is the Deputy Director General of the European Commission. So with the help of Agustina, I kindly ask to play the message of Matthew, who couldn't be physically with us today.
Hello, everyone. My name is Matthew Baldwin. I'm from the European Commission here in Brussels. And I'm sorry I can't be with you today here in Amsterdam. I'm delighted that the IRF, which of course has always been such an innovative organization, is launching a new committee on innovation at this very important meeting in Amsterdam. I'm sure your discussions today under Susanna's close observation and tutelage have indeed been very innovative about innovation. And I mean that in the broadest sense. We have to rethink our transport systems. It can't just be about incorporating, although of course that's important, the latest digital technology. So if I may, and I haven't been able to hear your discussions today, offer you 3 words about how we need to rethink our mobility in a much broader sense. The first word, of course, is sustainable. We have to cut our emissions from transport according to our new mobility strategy by 90% by 2050. We have to make a substantial contribution to the 55% reduction target by 2030. Right there is a home for innovation. The second word is urban. We are becoming an increasingly urban society. 80% of us will be living in towns and cities by 2050. And it's increasingly clear to me, at least, that we have to end our dependence on privately owned, conventionally fueled cars in our cities. We have to think about the external costs of our mobility. And mouth-watering, nearly 1 trillion euros a year is the external cost. We are not beginning to internalize it. And what's so interesting is if you look at that type of cost, it's about air pollution and noise pollution. It's about the cost of congestion. And last but not least, it's about the cost of road crashes. So our priority in the urban context needs increasingly to be on public transport, on active and shared mobility. And we're very keen to be incorporating those concepts as we move forward to have 100 climate neutral cities across the European Union by 2030. But my third word is safe. There is no sustainability without safety. All those people we want to get out there back on bikes, walking to school, they won't go on if we can't make it safe. We owe it to them to make it safe. We can make it safe. 70% of the people who die in our towns and cities on our roads are vulnerable road users. So that's a great focus for innovation as well. Thank you, Susanna. Thank you, friends. I'm really sorry I can't be with you. I hope you had a great discussion today, and I look forward to discussing these issues with you again in the future.
I think there was no better way to close this meeting today. I'd like to really thank from the bottom of my heart all the speakers, all of you who have been attending here in person and online. And I want to thank again the team, Agostina, Julia, Melin, Gonzalo, because it seems easy, but it's not easy to handle all these logistics in between the online and in person. Just a reminder, all the recordings, the presentations will be made available to you on the IRF website, and no need to write to us. We'll be reaching out to you directly as soon as they are posted on the website. Usually takes a couple of days, especially because we are now in Amsterdam and we'll be back on Friday. So by next week, you'll be notified about the presentation. Thank you very much again, and good continuation to all of you in Amsterdam and to all of you who are watching us wherever you are. Thank you and goodbye.